Hey guys, I'm Jay. Welcome to my LeetCode Review One Take vlog on 130th problem, surrounded regions. We are given an m times n matrix board containing letters x and o. We need to capture regions that are surrounded. We need to replace all o's with x in place within the original board, and we don't need to return anything. And let's see the example one here. We got an empty board here, and for the three O's here, they are captured and surrounded by X. So we need to flip the three O's into X. And for the O here, because it is on the edge of the board and cannot be surrounded, so we'll keep it as O. Then, let's get started with our intuition to solve the problem. And the key is, first, we need to identify all the O's that are safe, which means we need to find all the O's on the border or connected to the border O's. Then, we'll retrieve this by performing a depth-first search or breadth-first search, starting from the borders to mark safe cells. When that's done, we'll flip all remaining surrounded O's into X. And then let's get started with a depth-first search method. In the code, we begin by checking if the board is null or empty. If board.length if board equals null, or board.length equals 0. We just return because there is nothing to process. Next, we store the number of rows and columns for later use in our loops. Integer m is assigned to board.length. Integer n is assigned to board at 0.length. We then create a for loop to iterate over the first and last column for each row. For integer I starting at 0, I should be less than n, increment I after each iteration. For each row, we check the first and last column. If we find an O, we call the depth-first search method starting from that cell. If board at I 0 equals O. Oops. Then we call the depth-first search method with board I and 0. Then we need to handle the last column. If board I n minus 1 equals O, we also call the depth-first search method with board I and n minus 1. Then we create another for loop to handle the first and last row for each column. For integer j starting at 0. When j is less than n, we increment j after each iteration. And code is if board at 0 and j equals character O. We'll call that first search with board 0 and j. If board at n subtract 1 j equals O, we also call that first search with board m subtract 1 and j. After all safe O's are marked, then we'll scan through the entire board. we create a nested for loop to iterate over every cell. For integer I starting at 0, I is less than m, will increment I after each iteration. Here comes the inner for loop. For integer j starting at 0, j is less than n. We increment j after each iteration. And for each iteration, we'll check if it's an O. If so, it means it was not marked safe and is fully surrounded by X. So we'll flip it into X. If board at I, j equals O, then we'll flip it to X. Else if board at ij equals character X, we'll change it back to O because it's part of the safe region. Board at ij is assigned to O. Now, let's implement the depth first search helper method. Private void depth first search with 3 parameters. The first parameter is a character array called board, and the second parameter is an integer index I and integer index j. We start by getting the number of rows and columns in a grid. Integer m is assigned to board.length. Integer n is assigned to board at 0.length. Next, we check if the current position is valid and if the cell contains O. If not, we just stop and return. If I is less than 0 or I is bigger than or equal to m, or if j is less than n, less than O, less than 0, or j is bigger than or equal to n, or board at I, j equals character is not equal to character O. There's nothing we need to do, so we just return it. Otherwise, we mark the cell as safe. Board at I, j is assigned to character X, and the X stands for safe. Finally, we'll recursively call the depth first search method on 4 directions: up, down, left, and right. This way, every connected O from the border is marked safe. Let's start from the up direction. Depth first search with board and I, subtract 1, and j. Then depth first search with board I plus 1 and j, which is the down direction. Depth first search board I, j subtract 1, which is the left direction, and board I, j plus 1 is the right direction. When all the recursive calls complete, the depth first search method would return control to the main method. Alright, that's all of the code. Let's submit our code and check if our solution passed all the cases. Yes, our code got accepted. Now, let's analyze the time and space complexity. So the time complexity, the time complexity, it is big O of n times n. This is because the algorithm scans through the board several times. The initial board checks and depth first search calls ensures that each cell is visited only once. So the overall time complexity, it is big O of n times n. M is the number of rows and n is the number of columns. And for the space complexity, it depends on the recursion stack used by the depth first search method. In the worst case, when almost all cells are O, the recursion depth could be big O of m times n in a degenerate case. Therefore, the space complexity is big O of n times n in worst case. But in most typical cases, it won't be that extreme. And thank you guys for watching. This is the end of my LeetCode review blog on this problem, surrounding regions. And I highly recommend you guys to visit my online GitHub page here, which contains all the problem description, intuition, and main idea. Not only for the depth first search method, but also the breadth first search and the union found method here to solve the problem, and the final time and space complexity analysis. You can also visit my GitHub repository here, which contains all the codes and notes to build this online GitHub page. I'll put those two links on my YouTube description below. And thank you guys for watching. I'll see you next time. Bye bye.